Hello everyone, my name is Henry. I am a high school senior at Melbourne High School, New Jersey, and I will be giving a workshop and a talk about the Wolfram language and its services. So Wolfram language is a really powerful mathematical and symbolic programming language that can be used for almost any sort of application or service. To install the Wolfram language, you can go to this link in the Wolfram channel. If you click on this link, it will prompt you to make an account, and then once you have an account, you can claim the access to the language. You can also search up Wolfram language download, and if you have an account already, you can just download the Wolfram app from the website, and the app will come with the language, the kernel, and everything you need to use it. So I already have the app installed, so I'll go ahead and open it up. So it's just going to load, and you will be met with the application GUI here. You really just want to click New Notebook to make a new notebook, or you can press Control N, which will take you to this new notebook. So you can see there are a lot of buttons. I recommend you go ahead and play around with the buttons. However, there's only a few things that you really need to know to get started. So first of all, Wolfram is a cell-based programming language, which means there are cells of code that you can execute. If you've ever used Google Colab or the Jupyter Notebook system, this will seem very familiar. So I can make a new cell by pressing this plus button and pressing Wolfram language input. And so here I can now type something, right? So if I type some Wolfram code, let's say the square root of 9, I can then press this red button, or I can press Shift Enter to evaluate the cell. And so this is the cell input and this is the cell output, and so you can see that's how you can run Wolfram code, right? So I want to talk about first what the Wolfram language actually is, and then go over some examples. So first of all, Wolfram is a symbolic and a functional programming language. So everything is a symbolic expression. It is an object that you can manipulate. What this means for you, the programmer, is that it's really easy to use a language because there's no strict typing system. So you don't have to worry about the types of your variables, and there's a lot of built-in functions that you can use to get things done. So it's a really versatile language that can be used in a lot of different applications. One of the main benefits of the Wolfram language is that it has a built-in knowledge base. So it has a very large database that you can query for just facts about the world, and I'll show you this later. Furthermore, you can also build GUIs with the Wolfram language, and so you can make apps or services or websites that you can interact with. Finally, while the Wolfram language can be used for anything, it's really good at math modeling, language processing, and also some biology and some science research things. Now, I have a link down here, which is the link to the documentation of Wolfram, and I believe it's one of the most useful websites you can learn to, or you can use to learn Wolfram. So you can see there's these buttons which categorize every single function in Wolfram into these sections, and you can learn about these functions, right? So if I want to learn about, let's say, using Wolfram to solve calculus functions, I can click here, and it'll take me to all the calculus-based functions. If I want to build a large language model or a neural network with Wolfram, I can go here and I can learn about the functions for a neural network, right? So it's really versatile and very easy to learn. So I want to first get started and show you just some examples of how to use the language, and then I'll go over some more basics, and then I'll end off with some ways you can apply this in your own project. So first of all, I want to talk about the built-in database that Wolfram has. So if I type in this function called country data, this function can query Wolfram's country databases, right? So I can ask it to query something about the US, let's say, And there's all these different parameters on what I want to know about the US. And Wolfram actually knows all these things about every single country, right? So I can ask for an image of the country's flag. I can ask for its population. I can ask for its population, right? I can ask for its land area. So all these things I can query, right? Now, if you have the app installed, you can actually hover over the function, and it'll give you this book with an eye. And if you click on that, you can access the documentation for that function inside of the app, which is really useful and makes it much easier to learn what a function does. So this is one of the most powerful things with Wolfram, is that it can query all these databases and get you this very good and very reliable information. It's not just going to be limited to countries, right? I can also use these functions with words. So if I want to find a synonym for the word think, for example, it will query the word data indices, and it will give me synonyms for the word think. As you can see, word data, like country data, lets you query the database for some word and the information that Wolfram has on this word, right? So it's pretty useful, pretty cool. Yeah. So I really suggest you play around with these. You can use the built-in like autocomplete to learn what functions there are, and there are a lot of functions that you can test and try out. Now, Wolfram language is not just going to be limited to like a lookup engine. You can actually do much more with this. So one of the things I use it for a lot is math, right? So there's a really powerful function called the solve function. And if I enter just a basic quadratic equation, I can actually ask Wolfram to solve it for me. So I have this quadratic, and I'm asking it to solve for x. When will x when or for what values of x will this function be 0, right? So I'm finding the roots of the function. So if I run it, you can see it gives me the proper or the correct roots of this function. There's some other cool things I can do. I can plot a function. So if I plot the sign of x, I can set some boundaries for it from 0 to 10. You can see it plots the function sign. Now, there's a few things to note in the Wolfram language. So every single function starts with a capital letter, which may be different from what you've used in the past. Furthermore, to use functions, right, to apply a function, you use brackets, you use square brackets, right, which also might be different from what you used in the past. I can also make graphics, right? If I wanted to make a 3D cube, this is how I would do it. I can make this cube, and pretty cool feature, I can resize this image, and I can rotate this and play with it, right? Now, the good thing about the Wolfram language is that it is functional, and so you can apply these functions into other functions, and you can sort of chain functions like this, and it's really, really helpful and can be very useful. Now, I can also add variables into Wolfram, so this is very similar to what you might have used in other languages. I just make the name of the variable. Maybe I'll just say var. I'll set it equal to something. So let's say I want it to be like the number 3, right? Oh, here we go. I can now print var, which is equal to 3. I can add 3 to it, which is going to be 6, right? I can set the variable to an array or a list, depending on what language you come from, which I can use the curly braces for. So let's say I can just make this the list, and then I can index the list by typing in bracket bracket, and then typing in whatever index I want. Now notice the Wolfram language is 1 indexed for lists, not 0 indexed, so this would not work. In fact, I have to put in 1, so 1 refers to the very first entry in the list. I can also compose lists pretty easily. You might have done this in something like Python before. I can use the range function to basically loop. So this is a for loop, right? I can loop it through through these numbers, and so in Python this would be like for I in range from 1 to 10, right? You append something onto a list. I can use the join function to join two lists or to concatenate two lists. So I can so my first list is 0 is -1 0. Then I can join that with range 10 to get this bigger list. I can also plot a list with list line plot, and that's going to give me just the y values and the x values in the list. So these are all pretty useful functions. Obviously, for each function, you can go ahead and click on the docs, and you can read more about the function, which is really, really cool and really useful, and I suggest you use it a lot. Some more things about lists. You can have symbolic operations and list-based operations. So if I have this list, I can actually just do this to add 5 to every element on the list, which again makes it much easier to do complex operations with the language. And this just makes the Wolfram language really, really powerful for very fast coding. Now, there is a bit of a shift that you might have to put into your thinking to use this language, and because this is a very functional language, you don't really use for loops, right? You can actually have a function to generate the entire for loop for you, which is the table function. And so this piece of code right here is basically a for loop. This is the expression, and this is what we're looping between, right? So this will output this list of the numbers from 1 to 4 times 10, right? This is pretty interesting. So if you think about it, in Python, this might look like the code, right? We have a for loop, and we're appending something onto a list times 10. And as you can see, this is a different way of writing the for loop, and I really suggest you play with these functions and read about them to understand how I can implement these sort of loops in Wolfram without using a for loop, which might not be as functional. Right? Wolfram also has if statements, has while statements, all these things. It has switch cases, and you can just read the documentation on how to use them. They're pretty similar to how you would do if statements, maybe in like Python or in Java, and so I suggest you look at these as well. Moving on, the Wolfram language is really powerful as well because there's a lot of built-in graphical operations. So there's actually an object in Wolfram for color, and I can use the hue function to access and create color objects, right? And so you can see the hue function just gets you colors on this wheel, right, on the hue wheel. And then I can input numbers from 0 to 1 to get different colors, right? That's pretty cool. If I want to make sort of a rainbow of colors, I can make a table, and I can for loop for every number between 0 and 1 and incrementing it in steps of 0.05. And I need to have an X here. And you can see now I have a pretty nice rainbow and a gradient of colors. I can also make polygons, and I can make shapes, and I can configure them with the style command. And so style lets you format graphical objects with color or with some other styling, right? So I can create a graphics object, and I'll put it as a regular polygon, which is going to generate a polygon, right? If I want to make let's say a pentagon, I'll put in 5 for 5 sides, and I'll make it red. You can see I have a red pentagon now. I can make it orange if I want it to be orange, right? I can play around with this, which I think is pretty cool. You can also make interactive applications and GUIs in the Wolfram language. So there is a function called manipulate, which is going to generate or create an object that you can manipulate, right? You can interact with. So let's say I want to just loop over some things, right? So I will have a table. Let's say I just want to loop over some sort of color So that's how I would do it. So really what this is doing, right, is we're taking we're making a table of reds, so red objects, and then we're manipulating n, so we're duplicating these objects, right? Which, I mean, is pretty cool. So we have this red object here, and by moving this slider, I can drag it, and then I can copy this object however I want, and I can increment it by steps of 1, right? I can put in 2 here. You can see it increments only in steps of 2s. I can make this 10, which gets me more objects, right? So this is pretty cool, and you can really take advantage of this and make very complex GUIs. So I'll write a more complex manipulate function. So let's say I want to create a GUI to show the different types of polygons, right? So I will manipulate a graphics object, and I will style it. Let's say I'll make a polygon again, and this time I'll put in N. Maybe I also want to change the color of the polygon, so I'll put in a hue H, right? Let's actually make this a little easier. So you can see I'm manipulating a graphics object, and I'm going to style it with this hue, right? So now I can add in what I actually want to manipulate. So I can, let's say I want to go from a pentagon to a 20-sided shape, and I want the hue to traverse between 0 and 1. So now I have this GUI, I have this polygon. Actually, I'll make it start at 3. So I have this triangle, right? And I have 2 sliders that I can manipulate to change properties of this triangle. So the first is N, which I can change to change the number of sides, right? And then there's H, which I can change to change the hue, the color, right? So that's pretty cool. And obviously you can do a lot more powerful functions with this. I also wanted to go over how to process images in Wolfram, as I believe that will be really helpful for your hackathon projects. So I will just go find, let's say, like a random image. I'll just search up maybe lighthouse image. I'll take, let's say, this image of a lighthouse, right? Just some random image, doesn't really matter. I can copy this image, or I can save it and then drag it into the app. So I'll just copy it. And because Wolfram is very symbolic, you don't have to like initialize the image or anything. You can actually just Control V and put the image into the program, and Wolfram will recognize that as an image. I can also set a variable directly to the image, which is pretty cool, and then I can do some functions onto the image. So the first function is the blur function, which, as the name suggests, will blur a function. This number is just by how much it's going to be blurred by. And you can see what's really cool, you can directly input an image into a function. You don't have to put in a variable. You could if you wanted to, but you can actually just Control V and put the image directly into the function. There's some other cool functions. I really like dominant colors, which, as the name suggests, will provide the most common shades or the most common or the most common colors found in the image, which I think is really useful. Could be used for some data analysis of a large set of images. This one also is really nice, called Edge Detect. This might be good for character recognition, for facial recognition, anything that you need to draw edges for, right? And so you can see it gives you white lines for the edges, right? There's some other pretty cool things that I use a lot, and one of them is optical character recognition, right? So there's a function called rasterize, which converts a vector image into a pixel image, right? So it converts anything to a set of pixels. So if I rasterized, let's make this 100. So what I've done here is I've styled this text to be really large, right? 100, so very, very large font. And then I rasterize it, meaning now this is an image, right? If I didn't rasterize it, this would just be text. So you can see that this would be text. However, once I rasterize it, it's an image, right? I can no longer manipulate it as text. Now what's really cool is that I can use this as an image and I can run some functions on it. So I can edge detect it, and then I can get the edges of the characters, which is really useful. You can make some cool graphics with this, some cool designs with this, and I think it's pretty fun to use. Now, this is something really unique to Wolfram language, and that's accessing real-world data, right? So if I press Control equals, I get this sort of text box, and I can type in things I want to look up on the Wolfram language database, right? So I can type in the words United States and run this program, and Wolfram will actually use what you type in and predict what you want to say. So it knows that this is a country, and it knows I want to query some things about the US. So again, I can go ahead and query maybe its flag, right? And there you go, I can find its flag. Now, these are formally called entities, right? And so I can access properties of an entity with the entity command. So I can do the same thing as I did above by just creating a new country entity, right? As you can see, I just copy this over, about the United States. And so this is the same thing as here. There's a function called entity value, which will get you properties and values of the entity, which I also think is really, really cool. So for example, I can ask it about the United States, right? And I'll ask it, I don't know, what countries does it border? And I'll give you other entities that the US borders. And then I can query each of these entities and maybe ask for its flag. So now it'll give me the flags of the countries that border the US. Again, really, really cool and easy to use, useful tools, right? There's another really cool function for geography called geographics, which allows you to overlay things on maps, right? I can style this with a geopath, right, which is just a path from one place to another on a map, and I can, query from New York City, to Tokyo, and I will then, so you can see here, if I just run this, you can see there is a line going from New York City to Tokyo, and that is your geopath. And again, this is super, super cool for just being able to manipulate maps and doing things on maps, right? Finally, which is another really cool part of Wolfram, is the machine learning capabilities. So, I don't know, let's say I'll search a Ferrari, I'll get an image of a Ferrari, right, of a car, let's say this image. And maybe I want to classify the image, right? I want to do some image recognition. There's built-in models for this, actually, so you don't have to train or get a model yourself. There's built-in functions for this. So I can use the image identify function, copy in this image, and it will tell me that, wait for it, that this is a coupe, right? It's a car, it's a coupe, it's a two-door car, which is really, really useful. You can also do these things with text with the classify function. So I can classify, let's say, the sentiment of a sentence. I say, I love the Wolfram language. You can see it's a positive sentiment. If I put in I hate the Wolfram language, it's a negative sentiment, right? So you can do some text-based analysis here. You're not limited to just sentiment analysis. If you look at the docs for classify, you can see this is actually a general classifier function, and you can really use it to do anything you want to classify. You can make images. You can make it classify these creatures. You can classify features, and I think it's really cool, right? Now, importantly, if you look here, right, this function is actually giving the classify function, training data, right? These are the training images, and these are the labels, and it will actually be able to train on the data you give it, and then provide some answers, right? Another really cool thing is a function called feature space plot, and feature space plot will create a plot of a bunch of different objects based on their relation to each other, right? So I have this function on the side here with a bunch of images, and you can see there's a few images of cats, a few images of cars, and a few images of chairs, right? So if I run this function, it will cluster these images based on its features. So it'll cluster all the cars together, it'll cluster all the chairs together, and it'll cluster all the cats together. And so this, you can do a lot of cool data analysis and machine learning tasks with this function as well. So finally, I want to talk about actually publishing your projects to the cloud, right? So if I take this function right here, and let's say I want to make a website or a link that I can share with others, I can use the cloud publish function. And if you're signed into your Wolfram account, you run this function, it can actually provide a link for you to go to. So if I click that link, it'll open up a website with the GUI in it, so I can sort of share this link with anyone I want, and it'll work, right? I can I can use this however I want. So that's also pretty cool. Just some final Wolfram language tips and tricks. So there's a lot of knowledge bases and databases on Wolfram, which I want to cover. So the first thing is the Wolfram function repository. And what this is a bunch of functions that other people have made in Wolfram. So these are not like official functions, but these are functions that you can also query and use, right? So for example, maybe there's some image things I want to use. So for example, right, this function image mosaic, I can access it with the resource function image mosaic, and then I can run it just how I would any other function, right? There's also the neural net repository, which I also think is really cool. This is a repository of pre-trained, pre-built neural nets that Wolfram has. So maybe you've heard of Stable Diffusion to generate images. Maybe you've heard of BERT as a language model. There's GPT on here, right? There's a lot of different neural nets that you can use, right? There's GPT-2 that you can use. There's some facial recognition things that you can use. There's just a lot that you can play around with, right? And so I really suggest you start with the documentation. Where was it? Right, you start with the Wolfram language documentation, and then you can go from there. Finally, one last thing, there is a website called Wolfram U, which provides courses about the Wolfram language. I suggest you start off with this series to learn the Wolfram language. And if you click all courses here, you can see there's a bunch of interactive courses that you can go through. So this is a really good course, which goes through basically the entirety of the Wolfram language, and it covers a lot of really cool things that basically will make you a pretty well-versed programmer in the Wolfram language once you finish this course. Yeah, so that's really all I have for my presentation. I will be posting a formatted version of the code in the Discord channel later, so you can use it and see it yourself. Yeah, that's all I have. Thank you for listening, and thank you for tuning into this talk. If you have any other questions, please feel free to DM me or to ping me on Discord, and I would be happy to answer. Thank you. Have a good day.